Assalamualaikum warahmatullahi wabarakatuh. My name is YASMIN and I will be presenting question 1. An inverted conical water tank 20 meter high with a circular base on top whose radius is 5 meter. Water is running out from the bottom of the tank at a constant rate of 2 meter cube per minute. How fast is the water level falling when the water is 8 meter deep? So this is the picture of an inverted conical water tank with height of 20 meter and a radius of 5 meter. It also gives the statement that the water is running out from the bottom of the tank at a constant rate of 2 meter cube per minute. So now we know that the dV over dt equals to negative 2 meter cube per minute. The question was, how fast is the water level falling when the water is 8 meter deep? So now we know that it wants us to find the dH over dt when the water is 8 meter deep. So dH equals to 8. So first we have to write down the formula for a cone, which is 1 over 3 pi r square h. And then we can see here that there are two variables, so we have to make it as only one. You can do r over h equals to 5 over 20. We move h to the right, so now it becomes 5 over 20h. And then so now the r becomes 1 over 4h. Now we have r. We can substitute it into the volume equation. So now the volume is 1 over 3 pi in bracket 1 over 4h close bracket square. This can be expanded and now it becomes 1 over 48 pi h cubed. In order to find dH over dt, we need to find the constant rate for the volume. So now it becomes dV over dH equals to 1 over 16 pi h square. The formula to find dH over dt is dH over dt equals to dV over dt times dH over dV. So now we just have to substitute the data into the equation. Become negative 2 times 16 over pi h square. The h will need to be substituted with 8 because the question asks how fast is the water level falling when the water is 8 meter deep. So now the equation is negative 2 times 16 over pi in bracket 8 close bracket square. Now the answer will be negative 1 over 2 pi meter per minute. So this is how to find the water level falling when the water is 8 meter deep.
My name is Shame and I am solving question 2 for my group 1. So a ladder 50 meter long rests against a vertical wall. So I drew a wall along with the ground and this will be the ladder. And I just labeled this as y, x and length as in the length of the ladder. So we know that 50 meter referring to the length of the ladder. So it's 15. If the bottom of the ladder slides away from the wall at a rate of 1 meter, which refers to dx over dt. So dx over dt is 1. So how fast is the top of the ladder sliding down the wall, which basically means dy over dt. So we have to find dy over dt when the bottom of the ladder is 9 meter from the wall, which refers to x. X is 9. So we don't have y. dl over dt is simply going to be 0 because length does not change. It doesn't increase or decrease. So how to find y? We use the Pythagoras theorem formula. L squared is equals to x squared plus y squared. Replace with the information we have. 15 squared equals to 9 squared plus y squared. 225 equals to 81 plus y squared. Minus these two, 144 equals to y squared. Square root of 144 is 12. So we have here y is equals to 12. Okay, so now we have to find dy over dt. So we use the same formula. L squared equals to x squared plus y squared. We just differentiate the side. Equals to 0 equals to 2x dx over dt plus 2y dy over dt. We can cut the coefficient and we just have to bring the y dy over dt to the side. We have to, because we have to find the dy dt. So and then we just simply replace with the information we have. Negative 12 dy over dt equals to 9 times 1. So 9 divided by negative 12 is simply going to be negative 3 over 4. Convert it to decimal and we're going to have dy over dt equals to negative 0.75. The unit will be meter per second. Why is it negative? Because y is going down. It's going down the y. So it decreases. That is why dy over dt is going to be negative value.
Question 3. A cylindrical can without a top is made to contain 3 pi cm cube of liquid. Given the radius is r and the height is h. Show the area is A 6 pi over r plus pi r square. First of all, we need to draw the cylindrical can without a top. And volume equal to 3 pi centimeter cube. As we know, formula volume for cylinder is volume equal to pi r square multiplied by height h. If look at the question 3a, we can see that the formula for volume for this cylinder is in terms of r only. So what we need to do is we need to manipulate hash in terms of R. So we are going to apply proportion. Write the volume equal to 3 pi and replace V into formula volume for cylinder pi r square hash equal to 3 pi. So hash can be defined as 3 pi over pi r square. Pi divided by pi we can cut and hash equal to 3 over r square. Based on the question, we need to find the area of cylindrical can without a top. So the formula for area is 2 pi r hash plus pi r square. Replace hash into the 3 over r square and we can cut r and r square. 2 pi divided by 3 is 6 pi r plus pi r square. Final answer has been shown.
Assalamualaikum warahmatullahi wabarakatuh. I'm going to continue for question 3b. The question asks, find the dimension that will minimize the cost of the metal to make the can. From the question, we know that we're going to apply a formula of surface area, which is S equal to 2 pi r square plus 2 pi r h. First, we're going to substitute the value of h into the formula and do multiplication until we get S equal to 2 pi r square plus 6 pi r to the power of negative 1. Then we differentiate, we get S equal to 4 pi r minus 6 pi r to the power of negative 2. In this method of the derivative, we bring the r to the denominator to done the calculation easily. And the surface area, we call it undefined. It will become 0. Bring the 6 pi over r square to the other side and multiply both sides with r square. To find radius, we simplify it until we get r to the power of 3 equal to 6 pi over 4 pi, and we will get 1.1447 centimeter for r, which is radius. For h, we take the expression that we done before by substitute the value of r into the h expression. Calculate it, we get 2.2895 centimeter for h. Thank you.
Question 4. A closed cylinder can is to be constructed with a volume of 16 cubic meter. Find the dimension of the can, the radius and height, which will have a minimum surface area. Give your answer correct to 3 decimal places. The first one, we must draw a cylinder can. This is formula for volume and this is formula for surface area. And based on the question, volume is given equal to 16 cubic meter. First, take the formula for volume and equal it to 16. And we get the value for height. Like this. Next, take the surface area formula and change the value for h. This. Differentiate it. And it's become 4 pi r minus 32 over r square. dA over dt equal to 0. Then calculate it until we get the value of r. And the answer wants to correct to 3 decimal places, which is 1.365 meter for radius. At here, we already can get the value for surface area, which is take this formula and change the value of r that we get equal to 35.155 square meter. And lastly, to get the value of height, change the r value. And then we got 2.732 meter. That's it.